Welcome to the show, Xinshus.
Hello everyone.
So before we get into Zilliqa, could you tell our audience a little bit about your background and how Zilliqa came about?
Sure. By background, I'm a computer scientist. So I worked on cybersecurity for web browsers and then moved on to securing the control software components for larger scale systems, such as smart grids and transportation systems. But deep in my heart, I'm sort of a software person. And the blockchain is really a very exciting piece of software. And my PhD collaborator, Pratik Saxena, sort of brought me into this space when he started to talk to me about blockchain. I also personally got excited about it from the technical perspective. That's why I sort of joined into this industry and started to work on the blockchain technologies, first as a private blockchain deployments for bond trading. And then eventually we decided that we want to take this to the next step, which is to make it a very public and open platform. That's how we started the project Zilliqa in 2017.
So I recently found out that the name Zilliqa has a very interesting backstory. Could you share that story and how it aligns with your broader vision?
Yeah, it's a play on the word silica or silicon. If you look at that element, which backs sort of the whole computer industry, we also envision that a new platform like Zilliqa will empower the whole ecosystem of high throughput decentralized applications. So that's really our vision and our hope onto this platform.
Yeah, sounds good. I mean, I think it was very interesting. I found out last night during my research through your Medium blog post where you talk about going on the mainnet. I thought that was very interesting and something that our audience should know about. So Zilliqa is the first public blockchain that tries to solve the problem of scalability through sharding. I want to talk a little bit about sharding and scalability. But before talking about scalability, could you talk in very, very simple terms about what sharding is?
Sharding is one technology or a paradigm of different technologies that tries to solve this issue with scalability, or we can call it, scalability bottleneck in today's blockchain. So this is the issue that how many transactions you can process every second, whether it is 5 or it's 10 or some people envision that it needs to be thousands or tens of thousands. So that's the issue sharding tries to solve. By sharding, we mean that you divide the blockchain network of computers into different sort of groups, and then you ask each of the groups to work on a subset of the problems, and eventually you aggregate all the solutions together. So at the high level, this is about dividing and conquering. Of course, once you get into the details, how do you divide and how do you aggregate? When dividing, how do you make sure that security is not broken? These are some of the challenges every sharding proposal has to address.
Yeah, I think we'll go into a little bit more detail as we progress through the interview in terms of how the network is designed and also what a sample transaction might look like within the Zilliqa network. But before that, I want to talk about why choose sharding. So there are different ways to solve the scalability problem. For example, on Ethereum, there are some layer 2 solutions. You guys are obviously trying to solve the scalability problem within the blockchain itself on the layer 1. But there are also other consensus mechanisms like delegated proof of stake, which also solve the scalability problem, but may have some security trade-offs. So I just want to understand why you chose sharding and if there's any other ways that you considered to solve this particular problem at the blockchain level itself, at layer 1.
So first of all, there are different levels where you can solve this issue or where you can contribute to the overall solution of this scalability issue. As you mentioned, sometimes people can build layer 2 solutions, which will have a much higher throughput as well as much lower latency. So that's probably something very interesting and very promising. But on the other hand, you cannot just solve all the scalability problems without doing anything on layer 1. Because once layer 2, let's say layer 2 payment channels become popular, they still need some interactions with the layer 1. And then when the sort of throughput of layer 2 becomes very high, So that will become a burden on layer one blockchain itself. So eventually, you still want a faster blockchain, in simple words. On the other hand, layer two solutions are more suitable for certain types of applications where decentralization may not be a top concern. Where if you want much higher decentralization, you will still probably prefer a solution on layer one itself. So that's sort of the differences between layer one and layer two scalability solutions. I think eventually it's going to be a combination of both. They are quite complementary to each other. And if you want to support many different types of applications, you will probably need, different solutions. And compared to other on-chain scalability solutions, such as delegated proof of stake, I think there are trade-offs that every designer of the blockchain protocol has to strike. So, for example, delegated proof of stake can be very fast in reaching any agreement or consensus. But on the other hand, because depending on the level of delegation, sometimes with very high level delegation, you only have a few nodes or 20, 30 nodes making all the decisions. So that's what you just mentioned. It brings to this attention of security concerns, because attacking, let's say, 20, 30 nodes will be considered much easier than attacking hundreds or even thousands of nodes. So it doesn't mean that this thing is not as good as different other solutions. It also means that we look at what kind of applications, decentralized applications you want to support. So certain applications may have super high requirements on throughput and latency, and then you either have to choose payment channels on layer two, or you have to use sort of a heavily delegated proof of stake approach to get to that kind of requirements. But on the other hand, for other applications where you can afford some of the latency, then, and on the other hand, you also want a very high level assurance that things are running properly in a very transparent and open way and unbiased way, let's say. Then you probably want a solution like sharding, because it's on layer one. It's still a very open and transparent and decentralized solution. And on the other hand, it guarantees a very high level of security assurance.
So beyond sharding, is there any other way to solve the scalability problem on layer one, but still have a secure network or a decent level of security and also decent levels of decentralization?
I think the answer is it will be. There will be such solutions. But today, I think there are a few promising candidates people are exploring. For example, this DAG. There are several proposals around that, but still, I think people need to dig a little deeper into that and try to understand the different security sort of implications of different DAG directed acyclic graph solutions. So there can be other proposals coming up. I don't think that sharding is the only way going to solve the problem. But to me, at this stage, this is the most compelling solution if you want on-chain scalability and you want decentralization and security at the same time.
Yeah. So since we're talking about some of your competitors as well, and you mentioned DAGs, but let's talk about your direct competitors. So Ethereum is trying to implement sharding as well, but I guess from a timeline perspective, it's a little bit out. There are projects like Dfinity or Algorand that could pose as strong competitors as well. So they use this, new consensus mechanism called threshold relay, but they could also implement sharding. So how would you say Zilliqa stands relative to some of these newer projects?
I think we are trying to solve similar problems, but going after different approaches. So sharding is, as I said, you can call it a technology, or I would call it like a paradigm, where it guides you in terms of designing a protocol, and you can have quite different ways where you embrace this idea of sharding in your design, but ending up with quite different approaches. So what Zilliqa stands out today is that it has found a very empirical and a very feasible solution that it has already implemented into its mainnet. And there are many other interesting ideas we are going to explore, which will render maybe the Zilliqa solution or Zilliqa design quite different from it is today. But I think it's very interesting to see at least one of the blockchains implementing this sharding idea and making it work. We are open to looking at other different approaches. But one fundamental difference also is that Zilliqa has not adopted anything around proof of stake or delegated proof of stake because of many of our security and decentralization concerns. But that's clearly an interesting aspect that someone got to really look deep into that and see how do we make DPoS more secure and more feasible.
Yeah, that's interesting. So let's go a little bit more into how Zilliqa looks like. So what does the network design look like at a high level? And I think we touched on it a little bit when you were talking about sharding earlier, and what a sample transaction might look like if I'm sending, Zillinks, which is your native currency, to someone else within the network.
I think let me address the second question. I think the transactions will be very similar to Ethereum. Of course, the exact implementation and fields may be slightly different, but the high level idea is very similar. You can send transactions to transfer ZILs. You can also send transactions or whatever name you may call it to trigger smart contracts, to invoke smart contracts. And then the network architecture of Zilliqa is slightly complicated. So for example, you have two types of committees. One is called Directory Service Committee, which is the overarching committee governing many of the things. And then you also have the sharded committees, where they are the actual nodes forming groups to process transactions and reaching consensus. But we also have a slightly different peripheral network of nodes, which sometimes we call them lookup nodes, seed nodes, or things like that. So basically, those peripheral nodes are the gateways to access the network. The reason we are currently separating the lookup and seed nodes from the nodes who are actually running consensus is for security reasons, because we want to protect the network and we don't want all these nodes to be completely publicly accessible. So these are some of the design rationales behind why Zilliqa network looks like what it does today.
So I was actually familiar with the DS committee, the Director Service Committee that you talked about, and the shard committees as well. But there's another thing that you mentioned, which is the preferred committee. Is that what it's called?
No. It's like a sort of like peripheral network, okay, with nodes which will provide, let's say, API access to, for example, exchanges. Then these exchanges can host a node so that they have all the data of all the past transactions, all the current status, without having to be part of the consensus, which are really the nodes in the DS committees and the shard committees.
Okay, so I mean, while I was doing research, the picture that I had in my head was, I think Zilliqa is structured like a tree, so to say, with the trunk being the main layer or the top layer, which is the DS committee, as you call it, and then the tree has different branches, which are the different shards, and then the branches have different sub branches, which are the individual nodes. And so individual sub branches or nodes group together and form different shards, and then ultimately the block is appended to the blockchain through the trunk. So I'm just trying to figure out where the different nodes that you mentioned at the moment, where they would fit into this sort of bigger picture of how the network looks like. And I'm not even sure if that is a good analogy of how I described the network.
So from let's look at storage of blocks, because blockchain eventually is about a chain of blocks stored on nodes or computers. We have two chains in the sense. These two chains are linked. So one chain is about these blocks generated by the Directory Service Committee, and then we have a blockchain there. And then we have a second blockchain, in a sense, which is that it contains the transactions accepted by the shard nodes as well, sometimes in a specific case by the DS nodes as well. And then the blocks generating this in the second sort of chain will be linked to a specific block, specific blocks in the first chain. So that's how the blockchain is structured. But now this is slightly different from how do you generate such blocks versus how do you store such blocks. So if you look at these nodes who are running consensus, they are these nodes responsible of generating such blocks. And then they don't have to store everything, because if they have to store everything at the same time, they're just burdened maybe too much, especially considering Zilliqa is a high throughput blockchain. So that's why we also have other nodes who are actually storing these data. They don't have to be participating in the generation of the blocks, but they store them. And usually people don't even need such storage because they don't care. The only thing they care is I send you $5. So what's the final balances between our accounts? But there are specific applications such as, let's say, exchanges, such as things like Etherscan, basically block explorers. They may want to have the whole history of all the block data. That's the time they will either host a node to store everything, or they will interact with nodes who are storing everything. So yes, I have to confess that it's getting a bit complicated, but the complicated design, number one, stems from the practical needs. Number two is that we are looking into ways so that we can simplify things. But this is the architecture at this stage.
Yeah. So now I think things are a lot more clear. At least for me, I'm not sure if we lose the audience at this point. But now, I mean, it's very clear in my head, because so you've got sort of the main chain where you don't store the history of transactions, also because the transactions in Zilliqa are have finality, right? So you don't need to store the history, historical transaction.
In a sense that if you look at the chain, I mean, chain is a conceptual thing. Really, how do you store the information about the chain, and where do you store such information so that you can reconstitute the chain whenever needed? So that's how the design works out, where you have different nodes storing different data. But conceptually speaking, you can just think that it's as simple as two chains, and then all the chains are storing everything. So that's a conceptual level. So it's really down to the implementation level, where do we store such information?
Okay, got it. So I want to sort of switch gears a little bit and talk about the big announcement that you guys had recently. You went on the mainnet, and so I have some questions around this. So first of all, if someone wants to build on Zilliqa, but they've been building on another blockchain, say Ethereum, what's the process to port over to Zilliqa?
So we don't have like a turnkey solution at this stage, although that's something we've always thinking about in our mind, whether we can build like a tool chain which can almost automatically convert Solidity smart contracts into our smart contracts. We don't have that yet. So at this stage, it's still sort of a manual process where you need to translate your Solidity smart contracts into Zilla. It depends, because we have actually done some of this for our partner projects, and it usually doesn't take us too much time. Of course, depending on the complexity of the smart contracts itself, but usually that's a very minority piece in terms of migrating dApps. To me, I think migrating decentralized applications will require much more effort in other aspects. For example, do you want to redesign your user experience, your user interfaces, and how do you design this architecture? Will your application be across two chains, or will you be migrating some of your users from one chain to another, or you are actually opening up, let's say, a new sector of users on the new chain? I think these things really require more effort than just the technical migration of the smart contracts.
Could you talk about some applications that are building on top of Zilliqa? So there was one big announcement recently about HT Exchange, which seems to be like a securities token platform. A couple of other companies, I know Mindshare is one of the companies that is trying to build on Zilliqa as well. Could you talk about some of these applications and what you have in the pipeline as well?
Sure. So if you look at HT Exchange, right? So this is under the broader umbrella of tokenization. I think tokenization is still a very interesting application for blockchain. Although we are seeing ICOs having challenges, being questioned, but nevertheless, if you don't talk about ICO per se, tokenization, especially tokenization of assets, is still very interesting. Blockchain, especially public blockchains, provide an open and transparent platform to represent the ownership of different assets. So that's why we are working with several partners in sort of strengthening our strategy along this line. We do think this tokenization can be a very promising application for blockchain in 2019 and beyond. And the second application you just mentioned is about actually is about settlement at this stage in the digital advertising space, because you have many players. Today they are using very traditional means to do settlements. Sometimes it's not the most cost effective, not the most efficient way to do things. Using a blockchain, you can actually bring different parties onto the same platform, and they can see through things. There's nothing that anyone can hide from each other, and they will quickly using smart contract. They can quickly agree to the settlement options, and that can just improve the efficiency by a very large factor. So that's something we're seeing interesting in this digital advertising space. But of course, the same concept can apply to other industries. And on the other hand, I think just to boost sort of some of the initial interest on this platform as well, we want to work with gaming companies, because games can see adoptions much easier than some of the other applications. Because as long as you make the games interesting, gamers will just come to your platform. So that's why we are working with several gaming companies to create interesting games on Zilliqa as well. I think going forward, we're also exploring other sectors such as payments, for example. That's always a very interesting story for Zilliqa as a high throughput and high security blockchain.
Yeah, it's interesting. So I did see that Ethereum or the Ethereum guys are trying to build on your platform, which is interesting because we've had the Ethereum guys on this podcast as well previously.
Oh, that's interesting.
So in terms of, so we were talking about your mainnet. And we've talked about some of the applications that are building on Zilliqa, and what are some of the potential applications that could be built on Zilliqa, especially applications that need a high throughput. From a performance perspective, what's the performance been like on the mainnet versus what the performance was like on the testnet?
We don't have the data ready for the mainnet yet, because we just haven't got time to really properly stress test the platform. Of course, we cannot really stress test the mainnet, but what we can do is that we will have a testnet with exactly the same setting as a mainnet. Then we can stress test there. From what we gathered in the past, I think we could easily get thousands of transactions a second on our testnet. But really, with all the recent changes on the mainnet, we haven't got proper time to do that. But that's definitely something we're interested in doing, and we'll report once we have those data ready.
And how many nodes have joined the network already? Could you give us a view?
So you can actually go to explorer.zilliqa.com to see the current status of the mainnet. I think roughly speaking, we have 3 shards with about 2,400 nodes. But sometimes, of course, due to mining difficulty, some nodes may not be able to join. But that's the ballpark number. We have generated more than 15,000 transactions, and I think we have more than 900 nodes from the community at this stage.
So you said you have 2,400 nodes, but 900 nodes from the community, is it?
Yes.
Okay. Okay, that's interesting. And do you foresee sort of having around 800? So you mentioned 3 shards and 2,400 nodes. Do you foresee about having 800 nodes in each of these shards?
We now have 600 nodes in every shard.
Okay. That's interesting. So, taking a step back, so we've talked about sharding, we've talked about scalability, we've talked about how your network looks like in general. What are the people that are building on your platform, and who are the people that could potentially build? I want to take a step back and sort of, go more macro. So there are a few problems that exist at the protocol level with some of the Gen 3 protocols. I mean, depending on how you classify them, are trying to solve. So, there's scalability, which you're trying to solve. I've seen that you're trying to solve issues around privacy, robustness of smart contracts through implementation of formal verification. But there's one problem that I haven't sort of come across in your documentation or some of the other interviews that you've done, which is governance. What do you make of governance from Zilliqa's perspective? There are some projects that are trying to solve, I mean, there's 2 sort of camps. There's some projects trying to solve the problem of governance on chain. Ethereum is still, dealing with governance off chain. What is your view of governance from Zilliqa's perspective, but also, more broadly speaking, as a topic within the blockchain industry?
I think that's still a challenge. Honestly speaking, I do not think this is a problem that's solved, or people have really huge success story around it. I think there are a few proposals, but we still need to see how these proposals will pan out. So from Zilliqa's perspective, I think we will go offline in terms of governance before we can really have a good solution that's really convincing to everyone. A convincing on-chain solution, because I think one barrier is that Zilliqa token is a utility token. If you give token holders voting rights, there are chances that it may be deemed as a security token, which is not really our intention. So that's sort of a fundamental barrier for us to really work out some of the on-chain governance solutions. But nevertheless, we may explore some other ways around it. At this stage, I think we are sort of going after a similar route as Ethereum. In the beginning, this Zilliqa team will play a very influential role in spearheading, the directions of the project. But we have already started the process of engaging the community. And to a certain point, when the community becomes more mature, and then they can really sort of take on certain initiatives themselves, we'll be very supportive for those initiatives. And we will try to do things in a very collaborative way. And hopefully, after some time, can be a very long time, the community can really pick up this role of, deciding the future directions of the project. But, that's really going to be a long journey, I think.
Sure. But do you think, if there were no regulatory issues about ZIL being a security, if there were no constraints from that perspective, do you think on-chain governance could work at this stage?
Yes, I think if we don't have, or in general, blockchains don't have restrictions, in terms of utility versus security tokens, or somehow, that can be sorted out, it can be supported by the regulators. I think on-chain governance is definitely a dream for everyone in this space, because you just don't want this kind of out-of-band channel, right? You don't want that, imperfection. You just want everything to be codified in smart contracts, and then things can be decided automatically. That's a dream.
Okay. I think that's a fair point. Before we end, I want to get your outlook on the industry in general. Where do you think we're heading in the next couple of years? Any big things that occupy a mind share for you?
I think we are still trying. Not just Zilliqa. I think many of the other blockchains are still trying to figure out sort of what would be the focus area. In the beginning, everyone would probably just want to be a generalist. But going forward, I think we see increasing number of trade-offs and priorities you have to play with. So, for example, you can't have the best of everything. You can't have the fastest blockchain, with the highest throughput, lowest latency, highest decentralization, highest security. It's just there just doesn't exist anything like that. But what would be the focus area or focus applications, or the categories of applications that we really want to support as our top priority? So these are the things probably I think the industry has to decide on the individual project basis, and then prioritize the technical architecting and sort of technical development around that. I think that's what I see as a very exciting direction, and also a very interesting direction going forward.
So, what you're saying, and just to summarize, is that you see multiple blockchains with different value propositions, and then applications building on top of the blockchain, which is more suited to them, and then these blockchains interacting with each other through.
Yeah, I would love to have that.
Okay. Yeah, I think that was a very good discussion. Thank you, Xinshus. I know you're very, very busy. Thank you for taking the time to come speak with us.
Thank you very much.